So the purpose of this project was to build a race car, an air-powered car. We tried to make the car complete a 21-meter race in the shortest amount of time possible. Here is my car. I designed it on Tinkercad, which is a computer-aided design program. And I'm going to show you my design here. You can see that this is the body of the race car. These are what you glue to the edge of the car that allows the axle to run through those small little holes that you can see right here. And then these pieces right here are located right underneath the body tube that allow a good stable platform for this long body tube. And then finally, these are the wheels that I designed for the car. After I designed the car, it was cut out on a laser cutter. And then we, during the race, recorded a variety of data. And here is the Google spreadsheet that we made to calculate the speeds in both meters per second and miles per hour for each one of the drivers and their cars. You can see the launch pressure was constant at 90. The mass was recorded of the different cars, the time it took for them to complete the course, the distance traveled, and then we did a calculation to figure out speed in meters per second, and then we had the spreadsheet calculate miles per hour as well. The chart that we finished up with, you can see that John had the fastest speed of 14.34 meters per second. And then we looked at a couple of other parameters. In chart 4 here, we graphed to see if there was a correlation between mass and speed. And you can see that in this scatter plot, the plots are kind of all over the place. So we assumed that there was no correlation between the mass and the speed. And then in chart 5, we went to see if the diameter of the hole here had a correlation to speed. And it looks like there was a positive correlation. As you can see, the trend line that would fit along these dots with just a couple of small outliers. And that was also validated when we did the calculation. When we did the correlation between mass and speed, we only got a 0.13 correlation, whereas when we did the mass or the hole size and the speed, we've got a 0.77 correlation, which a correlation of 1 is a perfect correlation. The toughest or the most challenging part of this project was making sure that the nose cone would stay on the car when it was launched.